So now we will do load flow analysis. In that, firstly we'll talk about ybus construction. There we'll talk about sparsity. There we will talk about addition of row, addition of columns rule. Then we will talk about the formula for number of transmission line and so on. Then we'll talk about ybus modification. In that also we'll talk about 4 cases. Starting, first one would be addition of a transmission line between two buses. Second would be removal of transmission line. Third would be doing shunt compensation. And fourth one would be series compensation. So that we'll do in ybus modification. Then we will talk about zbus algorithm. In that also we'll talk of 4 algorithms. Firstly, it will be adding new bus to reference bus, then adding new bus to existing bus, then thirdly it will be adding a bus to existing bus. So initial two were addition of new buses, and fourth one was addition of bus between two buses. So this we will be handling 4 cases. Then we'll be moving ahead and we will talk about fault using ZBus. In that we'll talk about fault current. We'll talk about change in voltage at any bus. Then we'll talk about the flow of current, the amount of current flowing from the generator. How do we do that particular calculation? Then further we'll move into classification of buses. So in classification of bus we'll talk about PQ, PV buses. Then we'll talk about ref bus, generator bus, slack bus. Then we'll move into load flow solutions, wherein we'll talk about Jacobian matrix. We'll talk about number of equations in Jacobian matrix and so on. Okay, so let's get started with the first topic, that is construction of ybus. So always remember that sum of admittance of all connected, so sum of all admittances of a row or of column, meaning all the elements connected to a particular bus. Okay, for example, y11 plus y12 would be one which is connected to bus 1. So total admittances connected to a particular bus is equal to diagonal elements. Of diagonal elements is nothing but negative of admittance connected between the bus. Okay, that is y12. So number of admittances connected between 1 and 2. Then ybus is a sparse matrix. Ybus matrix is a sparse matrix. Percentage sparsity is total number of zeros upon total elements into 100. Now addition of any row will give or column will give admittances of that bus with respect to ground. So if you add total admittance of any bus, it will give admittance with respect to ground. Fine. So let us reiterate on the first rule, diagonal element. Diagonal element meaning all the elements connected to that particular load, okay, particular bus. But if you add all the elements of row or all the column elements, in that case we'll get the admittance which is connected to ground. So there is a difference between diagonal element and the addition of admittances of a particular row or column. Particular row or column will give admittances to the ground, connected to ground, and diagonal element will give sum of admittances, all the admittances connected to that particular bus. Fine. Number of transmission line is equals to n square into 1 minus x minus n upon 2, wherein x is nothing but sparsity. Whenever you add any transmission line, it will add two non-zeros to the matrix, and diagonal element of y inverse is nothing but Thevenin impedance of that particular element. Okay, so that was all about ybus construction. Now let's move ahead and look at ybus modification. Before looking at ybus modification, let us one time see the rules which we have seen above. So with help of this particular example, so we have said that the diagonal element, meaning all the elements which are connected to a particular bus. So let's talk about bus 1. So this one, this one, this and this four are connected, meaning 1, this plus this is nothing but 7. So minus 7 plus 1 is nothing but minus 6j. So diagonal element is minus 6j. Fine. But if you add a complete row, it comes out to be 1. Okay, it comes out to be 1. Now if you see for bus 1, this plus this is the total admittance connected to the ground that we got by adding all the row elements. Okay, that's what I was trying to tell the difference above. Fine. Now let's move ahead and let's see 4 cases. So if you add any transmission line between two buses, in that case 4 parameters will be getting changed. Okay, y11, y12, y21 and y22. Okay, I'll tell why. Since it is between bus, so 2 buses are getting affected. Now let's say you are adding in parallel, similar transmission line in parallel. Okay, fine. So what will happen here? Effective will become J6, here it will become J1, here it will become J1. Okay, here it will become minus J6. Now let's try. So since this bus is affected, this bus is affected, and between is also affected, this individual, so y11, y12, y22 and y21 will be getting affected. Okay, similarly if you remove also between any bus, if you remove between 2 buses, all 4 parameters will be getting changed. Now let's say you are doing the third case here is you are doing shunt compensation. Shunt compensation meaning what? Shunt compensation is only this. Okay, in this case there is no change in between the lines, there is only change at a bus. So only y22 and y11 would be changing directly. Okay, in shunt compensation you can directly give compensation to admittance. Okay, so 70% of, so since it is 30% compensated, we have directly, the resultant would be 70% of y, and only 2 parameters are changed as we have already discussed, y11 and y22. But what if case number 4, what if you do series compensation? In that case what would happen? In that case you can't straight away do compensation. You have to convert, since it is series, you have to convert y to z, then you will compensate and then convert again z to y. Okay, in that case since it is series compensated between bus, so bus will change, this will change, this will change and this will change. So y11, y12, y21, y22, all 4 parameters would change. Correct? So this was all about ybus modification. We have already covered ybus construction and ybus modification. Now we'll move to ZBus algorithms. As we have discussed that there will be 4 ZBus algorithm. Let's start one by one. So first 2 algorithms are addition of new buses. So first one is addition of new buses to reference bus. Second is addition of new bus with the existing bus. Okay. Now since you are adding one bus more, earlier let's say there were n bus system. Now since one more bus is added, now the dimension would become n plus 1. So now the dimensions are n plus 1 cross n plus 1. Let's say z old is some n cross n. In z new, what will happen is all rows and columns except z and n would change. So the order would be, let's say, z old, so whatever, z1, z2, z3, z4, z5 and so on. Rest last column and row would be 0. Just last element would be the updated impedance. For example, let's say the z bus is 0.2, 0.2, 0.2, 0.2, 0.5, 0.5 and 0.2, 0.5, 0.7. Now it says a fourth bus is connected with reference. So there are only 3 bus initially. Now fourth bus is connected to a reference. What happens now? Your z old will remain same as it is. Your z old new becomes, now new ka dimension is 4 by 4. Okay, in that your z old, which was 3 by 3, remains as it is. In fourth row and fourth column you will add all zeros except z44. Z44 will be replaced by zb. Okay, zb, which is the impedance of the new bus, added bus. Fine. Now when you add a new bus with existing bus, okay, in that also what happens is, existing bus, let's say the existing bus is kth bus. Okay, so there will be, so again what will happen is, you will have some kth row and you will have kth column. Okay, so last row and column you will update with that except z and n. Last element would be replaced by zkk plus zp. Okay, please look at example. Z bus of 3 cross 3 bus system is given. Fourth bus is added at bus 2. Now it is changed. It is not added to reference. It is added at bus 2. So k has become 2 with impedance zp is equals to 0.1. So let's let's firstly note down z bus old, and we know that z bus new is 1 plus dimension of z plus old. There will mark row and column of second row. We'll copy row and column of second row in fourth row and fourth column as it is. The last element which remains, there will add zkk, which is the intersection point, zkk plus zp. Okay, so that need to be taken care. When it was reference, all the nth row, n plus 1th row and column was 0 and the last element was zp, but here it is zk wala kth row kth column and last element is zp plus zkk. Okay, let's look at one of the examples. Now let's say if you want to construct z bus for the given example. Here what we can do is, first can be z bus, new z bus to reference. Okay, so new z bus to reference. Now new bus to an existing bus. Okay, 1 2. So in that case you will add copy first element in row column, and the last would be what, z intersection of that, meaning what, intersection of that is 0.2 plus 0.3. Similarly you can do for 1 3 also. Now let's see the other example. If fourth bus is added to bus 2 with impedance 0.1. So again, okay, fourth bus is added, so z second row and second column will be get copied as it is in the at the fourth place, and then the last element would be zp plus zkk. That is nothing but, you need to color it properly, and that will be, yes, so that will be 0.3. Fine. Now let's move ahead quickly and let's see the you can pause and you can do all these examples here, but for now let's move to the next case. Okay, adding impedance between existing bus. Now we are not adding any new bus. This is existing bus and reference bus. So kth bus and reference bus. In this there will be two cases. There can come two kinds of questions. There can come, here dimension will not change. Dimension will remain as it is. Since you are adding impedance between existing bus and reference bus, dimension may no changes. Now there can be two questions. They can ask you just to change in particular element. Let's say Z3, 1. They can ask only change in a particular element. If such question comes where they are not asking completely matrix, new updated matrix after addition of impedance between existing bus and reference, they are not asking that and asking only about a particular element, then you can use straight away a formula, that is ZAB new is nothing but ZAB old minus ZAP into ZPB by ZPP. Fine. Where ZPP is nothing but ZP plus ZKK. Okay, ZP plus ZKK. Now let's say what do you mean by that? Let's say you are adding to kth bus. You are adding impedance to kth bus. So ZAB new of that part, like let's say 1 3. You are adding impedance to second bus. Okay. And we are wanting change in first Z1. What happened to first changes. So you will find Z12, then you will write new is equals to Z12 old minus Z12 into Z21 upon ZKK plus ZP. Meaning, let's say you are adding to pth bus. Then what we will do? Then we will see pth bus ka that row and column may whatever we get, that becomes ZPP plus your impedance is ZP, that will become denominator, and in numerator, let's say you are asked to find Z12 and P is equals to 3, so it will become Z12 old minus Z13 into Z31 upon ZPP plus ZK. Okay, this is the formula. So what it is actually, ZAB old minus ZAB new, ZAB new equals to ZAB old minus ZAP into ZPP upon ZPP. Fine, that's about it. And if you need to modify complete matrix, then ZBus new is nothing but ZBus old minus XXT transpose upon ZPP. ZPP is same, ZP plus ZKK. But what is X here? X is nothing but kth column. X is nothing but kth column. Similarly, there is one more case. Okay. So similarly, there is one more. The fourth case in the series is adding impedance between two bus. So just like above case wherein we add impedance between a bus and reference, and there we saw two cases, right? Two cases in the sense two kind of questions. So question could be asked about change in particular element. At that point we write ZAB new is nothing but ZAB old minus ZAP into ZPP upon ZPP, where ZPP was ZP plus ZKK. And when complete ZBus is asked, at that point in time we use ZBus old minus X transpose upon ZPP, where X is nothing but kth column. Now since only one bus was involved there, we could use this formula. But what if there are two buses involved? There will be minor changes in this formula. The changes are x is nothing but jth column minus kth column, okay, and zpp is changed as zjj plus zkk minus 2jk plus zp. That are the two modifications which we need to make to the formula of bus changing, and that will give us the case solution for adding impedance between two buses. Now we'll see one of the problems which is related to ybus and could not be solved directly through the formulas which we have given. In such case, we will follow traditional approach. We'll normally write KVL, we'll normally write KVL, KCL, and then we will try solving it. Okay, you can pause this and check once. Now we'll look at the other topic, which is fault occurring at kth bus. Let's say fault is occurred at kth bus. At that point in time, I fault is nothing but V at that particular point, that is Vk upon Zkk, that is I fault. Now with this fault current, we can have change in voltage at any bus. Let's say delta Vi, delta V, or maybe kth bus also. If it is kth bus, then delta Vk would be what? Okay, let's do generalize. Delta Vi is what? Minus If into Zik. So what is change of voltage at kth bus? That would be minus If Zkk. At a jth bus, we have already discussed. And what does delta V mean? Delta V means V new minus V old. So to have new, we would need delta V, and to have delta V, we need If. Fine. Then there are certain questions asked on current delivered by alternator after a fault at any point. Let's say if fault is at bus 1 and they asked you current delivered at bus 1, that would be simple, right? Ej minus V1 new upon jxd. But what if bus is occurred at 1 and they asked you fault at bus 2? In that case, it would be V2 new, and V2 new would be what? V old new plus delta V2 new, and delta V2 is what? Delta V2 is nothing but minus If 21 Z21, okay? That you will substitute here. This in turn you will substitute here, and you would get the current. Fine. So again we shall see this one thing particularly. Current delivered by alternator after a fault. So current is nothing but Ej. Let's say fault at bus 3. Okay, and we are trying to find out I at bus 1. In that case, Ej minus Vi new upon Jx. But Vi new is nothing but V1 new. Okay, that's V1 new. So V1 new is nothing but V1 old plus delta V1, and delta V1 is what? Minus If Z1 3. Now and If is what? If is nothing but Vf upon Z 33. So since bus is since fault is at bus 3, so you will substitute If in delta V. Delta V, from delta V you will get V1 new. V1 you will substitute in ICA formula, and you will get current delivered by alternator at bus 1 because of fault at bus 3. Fine. Okay, now let's go ahead and see one of the examples dealing all the cases above discussed. So here basically Z-bus is given, and three-phase symmetrical fault occurring at bus 3 is given. Assume system is at no load and voltage at each bus is 1 per unit. Find I fault per unit. So fault is at bus 3, so it would be Z33, which is 0.7, and you've got the fault. Change in voltage at bus 1 would be what? IF minus IF into Z13. Okay, Z13 is nothing but what? 0.5. Please don't forget this minus sign in delta V. Okay, new voltage at bus 1, V new minus V old you could get, and then current delivered by alternator at bus 2 during fault at bus 3. That also you can calculate. Okay, you can just pause it for a while and check. Then comes load flow equation. In this we'll be majorly talking about, we'll get P equation Q in terms of del and V. So here basically there are 4 variables and we have only P and Q ka equation. So 2 equations. 2 are unknown always. So to get unique solutions, to get real solutions, we need to always have only 2 variables, as there are only 2 equations. So 2 sets of variables could be either PQ or they could be either PV. Okay, and using that only we have divided the buses into PQ and PV bus. Now PQ bus is called as load bus and PV bus is called as generator bus. In PQ bus P and Q are known, in PV bus P and V are known. So let's first talk about PQ bus. PQ bus is also called as load bus and we don't know, unknowns are V delta. Number of unknowns here are 2 into P into Q. Okay, 2 PQ. And since it is a Q bus, Q is fixed, so it has a fixed Q. And approx 80% of buses are load buses. Okay, there are less generator bus and more load bus. Now coming to PV buses are also called as generator bus. In that PV are known, Q and delta are technically unknown, but Q is certainly known. Okay, the only unknown is delta, and that's why here Q can be changed. Okay, and that's why Q is variable. Q is not fixed in this case. Questions are often so in questions you can see questions in couple of ways. It can directly say PQ, X number of PQ and Y number of PV buses, or it can say that some 10 generator buses are there. In that case you have to understand that generator bus meaning nothing but PV bus, and 5, let's say, load buses are given. In that case you have to understand that 5 are nothing but load buses, PQ buses. So whenever this PQ bus is added, you will, in Jacobian matrix you will see that 2 PQ gets added. Okay, 2 PQ unknowns get added, and when it is PV bus, then only PV unknowns are getting added. It can also, in question you can also see that a bus having fixed Q. In that case you have to understand fixed Q meaning it's PQ bus. It can say that a bus with variable Q. In that case you have to understand that it is a PV bus. One very important thing to note down is there is also a slack bus, which is a form of generator bus. So always whenever you are given some, let's say 50 generator bus, you for calculations will be taking only 49 generator bus and one would be a slack bus. Never forget that. Okay. Okay, let's get ahead. Now we'll see methods to solve. So there are majorly 2 methods we talk about: Gauss-Seidel, and other one is Newton-Raphson. So Gauss-Seidel is very simple. Again, Gauss-Seidel means what you do, you assume certain error. Okay, if you get 2 consecutive values less than that error, you will accept that particular value. What you will do is you will assume value x1. So it depends upon initial guess. You will substitute that and you will get particular value of x1. Then that x1 you will substitute, you will get x2. x2 you will substitute, you will get x3. Let's say x3 minus x1. The difference of 2 values comes less than 2, the assumed error. Then you will call it to be a linear. You will take that x3. You will accept it. Fine. So clearly it's a linear method. Time per iteration is less, but more number of iterations are required since it is dependent upon initial guess. Now Newton-Raphson, it is pretty simple. x1 is nothing but x0 minus f of x upon f dash of x. Okay, always it's non-linear. but it does not depends upon initial value. Okay, so we need to take care. These questions on this are pretty much often. x1 is equals to x0 minus f of x upon f dash x. Okay, then one last topic is remaining, that is load flow by Newton-Raphson using polar coordinates. So Newton-Raphson is mainly used for polar coordinates. So how you will have change in p with respect to del, change of q with respect to del, change of p with respect to v, changing q with respect to v. Okay, so one side you can see that p and q are changing with respect to del. Here you can see p and q are changing with respect to q, with respect to v. Fine. Now we'll come to Jacobian matrix. So this question is also very popular. Now order of Jacobian matrix. So order of Jacobian matrix is nothing but 2pq plus pv, that is number of unknowns. Here if someone asks you order for this order of some polar coordinates, one of the polar coordinates, in that case what we'll do is we'll take order in a way that knowns of numerator upon unknowns of denominator. Okay, we shall see example of it as well. For example, order of this would be what? Del p is known in what? PQ and also PV bus. Okay, and d del is unknown in what? Both PQ and PV. So order of the first one becomes this one. Correct? Got it, right? Now next, for this we'll see this is known in what? Again PQ plus PV, and del V is unknown in what? Is unknown in PQ bus. Fine. So you can check the order again we shall see for this one also. So del Q is known in what? It's known in, again it's known in what? It's known in what? And it's unknown in what? Okay, we shall see that. Okay, so this particular term here, this thing is known. So let's see where q is known. Q is known in PQ, and where del is unknown. It's unknown in PQ plus PV. Correct? Known, unknown. Now let's see for this also. So q is known in PQ, del V is unknown in again PQ only. Fine. So for this also, so the thumb rule is we'll do order of this could be find out as known upon unknown. Okay, known into unknown. So where all the numerator is known into where all the denominator is unknown. Okay, and order of Jacobian as discussed, it is 2pq plus pv. Fine, that's the order of Jacobian matrix. And one note point which is very important, that never forget slack bus. Slack bus is nothing but a generator bus, so we should never dare to forget that. We'll have to always subtract whenever generator bus or PV bus is given. PV is nothing but a generator bus. We can call it as generator bus or PV bus or variable Q bus. We need to keep in mind that we need to subtract slack bus if not given explicitly. With this we can wrap up this lecture. Thank you.